This assessment asks us to order the following carbocations from least stable to most stable. We'll say that 5 represents the least stable carbocation and 1 the most stable carbocation. The first thing we're going to do with this is look at how hyperconjugation stabilizes the carbocations, and for that we'll look at the substitution. So for example, this carbocation here is a tertiary carbocation, and we know that tertiary carbocations are relatively stable. This one here is primary. This one here is secondary, but we'll come back and say more about that one in just a second. This one over here is also secondary, and then this one is a methyl carbocation, so neither tertiary, secondary, or primary. With no hyperconjugation at all, the methyl carbocation is going to be the least stable, so we can go ahead and give that the 5. The next least stable is going to be our primary carbocation, so it will be 4 because it only has hyperconjugation one time. The secondary has hyperconjugation twice. The tertiary has hyperconjugation 3 times. We'll still come back to this secondary in just a second, but this is going to put this one as the third most stable. Now, how about these two? Normally, we would look at tertiary and say that tertiary has more hyperconjugation than secondary, but there's another thing that's possible here. Because this is an allylic carbocation, we can actually draw a resonance structure that moves these electrons over to help stabilize that positive charge. The fact that we can draw a resonance structure with this one means that we need to add here that there is secondary and resonance. The ability to draw a resonance structure means that that carbocation is delocalized over 2 atoms, and that's going to make a carbocation that is more stable than one that is just tertiary. So the tertiary carbocation will be the second most stable. The one that is secondary with resonance will be the most stable.